Okay, so how'd you do with these? Let's take a look at those solutions there, and did you get those two solutions there for both of them? Um, what I'm predicting here, and correct me if I'm wrong, but I'm betting 1B was probably, might have missed that one a little bit, or some of you might have had a little bit of trouble with that one. But let's just break this down one more time. If you look at 1A, and we'll come to 1B in a second here, because you have a common denominator here, we can just combine these two together. So 6x plus 3x, there's your 9x right there. Next, take the 5 and add a negative 1. That takes you down to 4 right there. Now what about your undefined thing? Hey, did you catch this here? That's kind of tricky. Let's see how we can get there. So remember, the denominator can't be 0, right? So one move that you can make here is to say, well, we can't let this thing be equal to 0, so now we solve by adding 3 to both sides, and then we got to take the square root, right? So one thing we got to remember when we take the square root is don't forget your plus and your minus there. So x can't be either positive square root 3 or negative square root 3. Okay, so looking at this one over here, once again, common denominator. What I do when I show my work on these problems, when I'm doing them on my own, I just slap some parentheses around there, and then I just tell myself, hey, minus this, minus that, and minus that. So looking at the highest degree term here, the biggest power in all this numerator stuff is just the 3x, is this x squared. So I want to take 3x squared and minus 2x squared. So 3 minus 2, there gives you your 1x squared. Next, look for any x terms, and there it is. So be careful. You see how this negative 3x turned into a positive 3x? Because this minus sign had to move in, and minusing a negative 3 actually makes it a positive 3, so positive 3x there. And then we got to take our negative 5, our minus 5, and subtract a negative 2. So we're actually adding 2 to that negative 5 to put us at negative 3. Notice our denominator is 3x minus 1, so if 3x minus 1 can't be equal to 0, then if we add 1 and then divide by 3, there's our 1/3, so x can't be 1/3. Okay, so this next little exercise, I know I don't have this on your note sheet, but we're going to move up this little slider here in difficulty level and just kind of go from early on when you were learning with fractions to what I'm going to be expecting you guys to be able to do now that you guys are all high-flying mathematicians now. So taking 5/6 and adding 1/3. Boring, right? We know all there is to know about these. Remember, with adding fractions, you need a common denominator, right? So I'm going to break this down ridiculously a lot. So try and stick with me here, because every painstakingly step I put in here has a meaning when we're going to be moving on to the polynomial stuff later on. So take a look at this. What I did here, if we click back and forth, is the process that you would have done here when you're trying to get a common denominator, right? The common denominator here is going to be 6, right? We all knew that. But let's break it down even further. How we get it to be 6 is if we look at the factors. 6 is the same as 2 times 3, right? And when we look at both the denominators here, notice that they both share a 3, and that the 6 over there had a factor of 2 in it. So when it comes to finding a common denominator, what you guys would do, almost without even thinking now, is you knew just to double the denominator over there, and what you do to the bottom you have to do to the top, right? So that move there that we're looking at right here is when you had, back up here a little bit, when you had everything factored down below, when there was 1 that was absent there, we had to put it in its place there. And then what you do to the bottom, you got to do to the top. So then we simplify that. There we go. And then we can add those up. 7, 6. Easy. What about this one, where both the denominators there, 8 and 12, could be factored? One move that you would have done here, or could have done here, to find a common denominator is multiply 8 and 12 together. It wouldn't be the smallest common denominator. What you probably would have done here is counted by 8s and counted by 12s and found, what do they call that? The least common multiple, right? LCM. You'll probably see that in the book. So the least common multiple here is 24. But let's get ridiculously picky with this. 8 and 12. If we factor 8 and 12 down to just 4 times 2 and 4 times 3, notice they share a factor, and that's 4. There's a 2, a factor of 2 in the first fraction. The second fraction has a factor of 3. You guys already told me the common denominator was 24, right? Tell me, I'm kind of guessing you guys knew the common denominator is 24. But if the common denominator is 24, what we can do here is notice that we have a 4 here and a 2 here. We have a 4 here and a 3 here. So what that means is that this guy over here is jonesing for another 3, and this guy over here needs a 2. So if we give that other one a 3 and we give that other one a 2, what we do to the bottom, we got to do the top. And now we get our common denominator 24. If we back it up here a little bit, 3 times 3, that gives you your 9. 5 times 2 gives you your 10. You guys have been doing this for years now, right? I'm just really breaking it down into steps here, because these steps right here that you're seeing of factoring, finding the missing factors to get your common denominator, is what we're going to be using when we move on to monomials and polynomials. So let's take it up a notch and look at monomials here. So a common denominator. Let's just break that denominator down there into steps, and let's just look at it, the coefficients first, the 3 and the 2. What would be the common denominator if all we had was just a 3 in one fraction and a 2 in the other? It would be 6. That's going to be the same thing when we're dealing with monomials here. Move on. What about the x squared and the x? What would be a common factor there? Well, all we'd have to do with the x over here is multiply it by one more x. So I think the common factor there would just be x squared. Move on to the y's. We'd have to multiply this y here by 2 more extra y's, and then we'd have them saying the same things, y to the third. So our common denominator here is going to be 6x squared y to the third. So then we break it down even further. Just look at this one over here. What does this expression, this monomial, need to become 6x squared y to the third? Yeah, that 3 is going to need a 2, and that y is going to need 2 more y's. In other words, we're going to multiply that by 2y squared. Over to the other side, 2xy cubed. We need to multiply the 2 by a 3, and we need to multiply by 1 more x to make that x squared there. The y cube's fine the way it is. And then, just like with any fractions, once we have the denominator and we're getting a common denominator, what we do to the bottom, we have to do to the top. So what I'm going to do right now is I'm going to clean up that denominator. If I multiply these together, of course, what we're going to expect to get here is that, right? So 6x squared y cubed. Now let's multiply the top over here. Wouldn't that be 4y squared? And over there would be 15x. And then let's just combine them together and write one fraction. Now that we have a common denominator, there we go, and that's the best we can do. Remember, we can't cancel this stuff because of that stinking plus sign that's right there. Okay? Now let's take it up another notch, and let's look at adding polynomials. So when it comes to adding these polynomials here, the first thing that we have to do, once again, don't cancel. What we have to do here is factor first. If we can factor both denominators, it'll be very easy for us to spot the common denominator. So which one of these two denominators can be factored? You guessed it, that one right there. X plus 1 is prime, so we aren't going to mess around with that. But x squared plus 3x plus 2, we can come up with two numbers whose product is 2 and their sum is 3, right? That's pretty easy. X plus 2 and x plus 1, right? Now take a really good look. They have a common factor of x plus 1. But notice that the left fraction has an extra x plus 2. This other fraction over here needs to have an x plus 2. And then we'd have a common denominator. So we put an x plus 2 over there. And what we do to the bottom, we have to do to the top. So where do we go from here now? It's the simplifying stuff, and this is where a lot of students get kind of really confused on the steps here. Understand that your focus needs to be just right here with multiplying those two fractions together. Remember, multiplying fractions is easy, so don't complicate it. Just top times top, bottom times bottom. So understand, if we really wanted to do this multiplication, why don't we just do distributive property, right? We take that x and multiply it by both of those two things here. And so that would give us our x squared plus 2x. Now that we're there and we have a common denominator, now let's just add these up and let's just combine like terms, right? So x squared, nothing to combine it with. The x and the 2x, that's going to make a 3x. And then the minus 1, no one to dance with him. So we have minus 1 there. So there we have it. I'd like you to pay attention to something here really quick before we move on. Do you notice this numerator here cannot be factored? It's impossible to come up with two numbers whose product is -1, their sum is 3. What we're going to do is we're going to take this up a notch. Slider there. And let's take a look at this one and see if that same thing happens where the numerator can't be factored. So here, what do we have to remember to do first? To find a common denominator? That's right, baby. We've got to factor first. So if we were to factor this thing, which denominator can be factored? That's right, the second one there, x squared minus 9. So we can factor that into x plus 3x minus 3. So just like the last problem, what do they have in common? They already have that factor in common. This guy over here is sad. Why is this guy sad? I want what he's playing with. He's got the cool toy. I don't got that cool toy. You ever have siblings that are like that? I know I did. So, fractions, common denominators, they're a jealous bunch here. They always want what the other guy has. So if this guy has an x minus 3, this guy wants an x minus 3 too. So we give it to him. Say, here, are you happy now? Yes, and he's happy. Hence the smiley face. So, now what do? Once again, your focus should just be right here. Just multiply those together. We got to do distributive property again, right? So x squared minus 3x over there, up top. And then when we combine these numerators together, hey, nothing really combines together here, so now we're staring at this, right? X squared minus 3x minus 18 over x plus 3x minus 3. Notice what's different this time from the last one we had. See that numerator? Is it possible to factor it? Yeah. So what we're going to be doing here, we can factor the numerators, and occasionally when we factor those numerators, it's possible that we can reduce it. This is the thing that students always forget to do, is look to reduce the fraction. Do not look to reduce the fraction until you've taken two fractions that we had right here, and when you combine those together to make one, then look to reduce it. So how do I reduce it? Once again, we have to be able to factor. Clicky. Got to be able to factor this here, so product and sum. I think we can get away with doing, what, a positive 3 and a negative 6. And then you know what to do from here, right? Those x plus 3's, say goodbye. And then look at what we have left. X minus 6 over x minus 3. We did it. Reduce the fraction also. Great. Remember, don't get too cancel happy, right? Don't make Darth Vader come back in here. Can't do that, can we? No can do. So don't cancel that. So, taking a look at this. Let's add these up. And then notice the other part here, and you're going to be asked to do this on your assignment. Identify any x values which the expression is undefined. You know what I would suggest you do is I suggest you do that right after you factor the denominator. Hey, another thing to notice here, I get students doing this a lot, and I think it's just because they are thinking about the multiplication problems that we were doing in 8.2, is they love to try and factor that right there. And you could factor. I mean, sure, you could take out the 2 and call it x plus 3. But whenever you're dealing with an addition problem or a subtraction problem, it's best to leave those numerators unfactored. Why? Well, if we go back here, all the way back here, and when it comes time to looking at this right here, do you notice we could have factored out an x right here? It's best when it's unfactored, so that way it's easier to combine those things together and make one fraction out of it. So since that's our destination here, let's not factor this and make it more complicated up top. It's going to be easier to combine those and make one fraction when there is nothing being factored. In other words, no parentheses up there. But what you're going to want to do is factor this down here. So I think I've stalled long enough here. What's that factor into? Yeah, this is an easy one. X plus 3 twice, isn't it? So once again, here comes the jealous fraction here. I want a second x plus 3. So give it to him. Let's get this 3b number out of the way. Sort of. And make him get a little bit more faded out. Bye-bye. Alright, so now we give this guy a second x plus 3. What happens next? Right. Let's get rid of these parentheses here. Remember I was talking about how these are great without parentheses? The only way you're going to combine these together and write as one fraction is if you get rid of those parentheses up there. So let's get all distributive property on this. Now I'm going to write the rest of my work down here. So down here, now I have x squared plus 3x. And then over here, plus the 2x plus 6. Little tip here, when you're showing your work, I always found it obnoxiously annoying to keep on copying down the same denominator over and over and over. You see how many times I've been writing these x plus 3's? So I'll give you a little tip, a little bit of a heads up on how I used to do this work. When I was showing my work on these problems, I actually didn't bother writing down the denominator until my very last move. Why? Because the denominator never changes throughout the work that we're doing here now, does it? So watch me do this. I'm going to leave this denominator there and just assume that's down there. Just save myself some writing. Because really all the action is taking place right up here. So if I need to add these together, x squared, okay, so let's just call this x squared, and then the 3x and the 2x, that makes 5x, and then plus 6. Now, understand I still have that denominator here underneath of that. Remember, I'm just kind of skipping through writing it. But then, remember, this is going to be the time where we look to factor to reduce our fraction. So let's do that here. Can we factor x squared plus 5x plus 6? Oh yeah, we can. What would that turn into? X plus, what, 3 and x plus 2? Now guess what I do? Now I bring back that denominator that I was avoiding writing down so many times, because now doesn't the denominator become relevant here, finally? Because now what we can do is, whoosh, that divides out to be 1, and so now we're left with x plus 2 over x plus 3. What else do we need to do here? How about that? Undefined values. Now where's the best spot to do it? I think I was saying this earlier. The best time to do it, certainly not here. Remember from our multiplication work, you don't really want to look at the final answer. Wait a second, the final answer in this one, there's really not much difference. But once you factor and look at all of the denominators in the original problem, take a look at all that before we start working with it right there, and then find your undefined values from there. So pretty much this works as long as x is not equal to what, ladies and gentlemen? Yeah, -3. Okay? And there's the solution right there. How does the game change when it's a subtraction problem? Not much. You still have to find a common denominator. Take a good look at this one though. Let me get the 4a out of the way here. This is the example right on your note sheet. See you later. And let's dive into this one, shall we? Can we factor either one of these two denominators? No, we can't. So what do we do for as far as a common denominator? Let me show you a similar problem. If I were to grab that slider again that was, that slider was down here, and move that slider all the way back to when we were dealing with integers. Take a look at this problem. What if I wanted you guys to take 1/5 and add 1/2? What's the common denominator? It's 10, right? And how do we get 10? Couldn't we take this and multiply this by 2? and take this one and multiply it by 5. In other words, all we really did is just took whatever the other denominator was, we just multiplied it on the other fraction, right? So let's go ahead and do the same thing here with this one. So in this case, let's multiply both the top and the bottom here by what? Yeah, let's multiply by that 5x minus 2. And then over here, yep, let's do x plus 5. Alright, now that we have this on both sides here, now this is where the subtraction problem really starts to differ itself from the addition problem. Nothing different happens over here on the first fraction, right? So once again, I'm going to kind of hesitate to write down the denominator here because nothing really exciting happens yet. But the real action happens up here. So we got to FOIL this puppy up here, right? So that makes it, let's see here, 15x squared. And then minus 10x. And then inside would be minus 6x. And then last times last would be a plus 4. How about I clean up that middle term there too while I'm at it? Negative 10x minus 6x, and then I can make negative 16x. And then the plus 4. Now here's where you got to be on your toes. When we multiply this together using the distributive property, here's my suggestion. Put a positive 2 in there. Ignore that negative sign right now. Just worry about putting a 2 in there. And if I'm ignoring the negative sign, the minus sign, we still have a minus sign right there. And then over here, now we have what? We have 4x plus 10, correct? Now subtraction, just like what we saw earlier, that second fraction right up here with that minus sign, we had to distribute that minus sign to both of those two terms in there. So we're going to have to do the same thing on our problem up ahead. So we need to subtract and distribute that minus sign and subtract 4x and also subtract 10. So when I do that, 15x squared, hey, nothing happens there, so we have 15x squared. And then we got to take negative 16x minus 4x. That makes negative 20x. And then 4 minus 10, that make a minus 6, wouldn't it? Now, yikes, looking at this numerator here, I'm pretty sure this sucker probably can't be factored. So now what we're going to do is now let's bring in that denominator of 5x minus 2 and 5x plus, not 5x, this is what, 2x plus 5, right? Boom. Uh-oh, undefined values. So if that's our solution, what can x not be equal to here? Well, now we have to look at each one of these ones here, right? This one, undefined value, as well as this one here and its undefined value. So setting the red one equal to 0 when we have to subtract the 5 and then divide by 2. And then also the next one, add the 2, divide by 5. Those are undefined values. This is our final answer. There we go. So a couple more problems here, more of the same, factoring and canceling. Notes for future math. I'll be seeing you guys probably pretty soon in another video here, wrapping this stuff up, showing you a couple more tips. Maybe looking at some homework problems too. So keep on working on these, and we will on these homework problems, and I'll talk to you tomorrow.